So I'm Dr. Anderson. This is the second in a two-part series for the program R. And this workshop is focused on basic data analysis in R. Tonight, the workshop is going to be a little bit different than the workshop last week. Last week, it was largely you watch, ask questions as they come up. Tonight, I have built in into this workshop a lot more interactive components. So if you would please go to this website, the research.library.gsu.edu/R, and it's in the chat. And one of my colleagues, I'm sure, will post the link in there. Again, phenomenal. Thank you so much. And I'm going to do a brief spiel in the beginning about research data services, just like last week, for those of y'all who were not here for last week's presentation. So I'm a faculty member of a team called Research Data Services. We're a group of faculty members that are housed within the library, as well as one graduate research assistant. If you're interested in talking with any of us, these are our different specific areas that we work in. For Georgia State folks, y'all are able to reach out to us to do individual or group consultations. We work with people quite a bit one-on-one. Two of my colleagues are here tonight, Jeremy and George. So Jeremy is a faculty member in Research Data Services who's also a quantitative methodologist. He's introducing himself in the chat. And then George is also here tonight. George is my graduate research assistant, and he's great at quantitative methodology as well. Both Jeremy and George have extensive background in R, so the three of us use it quite a bit. George just finished, well, he's about to finish his thesis in R, and I think that R is Jeremy's main program, so we all have quite a bit of background in it. If you're interested in anything from data services in general, you'll check out this website. And you're in one of the last two workshops offered this semester. I'm teaching R tonight, and I'm teaching a SAS workshop tomorrow. And that will conclude the workshops for the spring semester. But all of the workshops that we have done since we have moved to online are posted on a website. I think, George, if you would post that in the chat, and then you can watch the workshops if you would like. If you attend or watch 5 different workshops, data certification. The data certification is free and it's available to everyone. So if you're Georgia State or if you're at another institution, if you're a community member, you're able to do this data certification. The requirements are very simple. You need to watch or go to 5 different workshops in one semester. There are more than 5 workshops posted on the website that Jeremy just posted. That's a recording. If you go to 5 different workshops by 8 a.m. on April 20th, you can earn this data certification. The cutoff is strict, so it needs to be by 8 a.m. on April 20th, and we're in the Eastern time zone. If you're not in our time zone, please be aware that we're in Eastern. I run in the summers. It's called the Graduate Research Intensive Program. This is open to graduate students at Georgia State, and it's a 2-week intensive of 70 hours over the 2 weeks. And we cover general research, and we really focus more on quantitative methodology and mixed methodology. Last summer was our inaugural year. We had about 250 applicants for 20 spots. This program has a small fee to be in the program. It costs $40, and that $40 covers your notebook, your jump drive, and other things like snacks. So this is a program that's in August. Currently, it is still on, and we are hoping to keep the program on. It is an in-person thing on the Atlanta campus. So let me go back. There's been a couple questions that have come to the chat about RDS. So how is it possible to check the number of workshops that you've attended? This is a good question. Every time you check into a workshop, we send you a follow-up email. So when you check in tonight, you'll get a follow-up email and say you went to R2. What you can do is search through your email and see how many of those workshop emails you have. Now, this is an important thing to note. You have to go to 5 different workshops in this semester. So if you have emails from attending last semester, that does not count. It is only this semester. So that's the way to check the number of workshops that you've been to. If you happen to realize that you checked into the workshops under 2 different email accounts, this is an issue. At Georgia State University, we have over 50,000 students, and therefore we have multiple people with the same name that attend Georgia State. So how we differentiate who is we use our email addresses. So if you checked in under multiple email addresses, you need to reach out. You can reach out to me via email, and I can go into the system and adjust it so that all of your email addresses are the same. Please avoid this. This is a pain and it's tedious for us to fix, but we do it. We recognize it happen. So the best way to check the number of workshops you've attended is going into your email and checking the confirmations. Of note, if you watch one of the workshops that are posted online, you can still check in. So let's say that you're attending R2 tonight, but you missed R1. The R1 recording is up online, so you could go watch it, and then at the end there's a link so that you can check into that workshop as well. Another question came in to me, but it came privately. So if you post questions, try to post them to everyone so that Jeremy or George can try to address them if I don't have time or I miss them. The question is R1 and R2 different workshops, or should it be R or SAS? So each workshop in the series counts as a separate workshop. So if you come to R1 and you come to R2, that counts as 2. So you could go to a series and it counts for 2 or 3 workshops based on how long the series is. So my Stata series is 3. So Stata 1, Stata 2, and Stata 3 counts as 3 separate workshops. So you can mix and match them, or you can do entire series. But the important part is you go to 5 distinct ones. So if you really want to know Python and you go to Python 1 twice, that only counts 1 time. Are there any other questions, comments, or rude remarks about research data services, the data certificate, or GRIP that you have before we get back into R? Okay, so I'm going to close this out to the check-in slide at the very end, so you don't have to worry about that until the end of the workshop. And I'm going to go ahead and open up RStudio. And I'm going to pull up that website that I asked y'all to go to as well. So let me zoom in a bit. Come to the R workshop, you'll notice that the homepage is pretty bland. I'm going to go to the R2 workshop materials. Please follow along. Please pull this up. It'll make your life really, really helpful. So just really quickly, somebody asked in the chat, is there a limited number of spots for the GRIP program? Yeah, GRIP we only accept 20 people a year. So last year we accepted less than 10%. Oh, George we have about 25 spots. Last year we only accepted 20 because sometimes we have computer issues. So we accepted 20, but we had 25 technical spots. Okay, so I'm here on the R2 workshop material page. If you, after this workshop, want to download R, there's a link right here to download RStudio. So you need to download both R and RStudio. They work together. Then if you would please, this is the thing that's important for tonight, even if you are not using R on your own computer and you're just following along, please download this handout because I'm going to be asking questions. I want you to be able to reference the handout because the handout contains the code. So I'm going to open the handout so y'all can see this right here. Okay, so let me zoom in. Let me go to the. You'll notice here that I have different sections. There's 2 sections, a part 1 that's the code and part 2 that's the output. So if you would please open this up and look specifically at part 1, which is the code. The reason I'm asking you to do this is so that later if I ask you, how would you write this code or how would you edit this code, you can have a document on your computer open so that you can see the previous code and mirror your code off of it. Okay, so I'm going to minimize this. I'll probably open it up later, but this is what you're looking for, and it's the handout under R2. It's important that you download the handout for R2. There's a handout for R1 and a handout for R2. You want the R2 handout. Let me minimize. Right below, you'll see that there's a big block that has, so I'm just going to copy this over and paste it into my script window. So this is your landing page for R. Remember that this is the script top. That's where you have your code. And then down here is where the output is produced. So I'm going to paste this code in. And you'll notice that the code is much shorter than last time. We only have 189 lines of code tonight. And I think we went over more than 500 lines of code. So the biggest thing that's different is I remove the annotations, the heavy amounts of annotations, because most code doesn't have that much. There's a lot here at the beginning, but you'll notice later on there's not as many annotations. And remember that annotations are going to be those notes to ourselves in the code. So at the beginning of each line of annotation, you'll notice that every green line starts with a hashtag or a pound sign. So when you have that in there, it tells R that this is going to be a note to myself as the researcher. Do not run this. This is not analysis. So you should use these very intelligently. I met with somebody who's actually in the workshop today earlier this week, and he had really great annotations in his code in a different program. And it helped us when we met to really talk about what are the different factors, what is he attempting to do, what are his research questions. So you want to use annotations very intelligently. I like to use annotations as even put websites in there. Like, here's a good example of how to run this code, or here's the journal article that I'm mirroring after. So please make sure you use these heavily. And so this is just an introduction to what we talked about. So we're going to go over a couple of things that we did last week to get your brain juices flowing, and then we're going to start doing newer stuff. My biggest goals for tonight is for you to know how to make variables in different contexts, and also for you to know how to run some basic analysis like a linear regression. So what we're going to cover tonight will cover most of data manipulation, things like how do I make a variable that copies an old one? How do I make a variable that is binned or collapsed? Things like that. So tonight's going to be a bit more heavy hitting code, a bit more data management focused. So we have plenty of time. Ask all the questions that you have in the chat, and I'll make sure that we pause and answer them as we go along. R is not for passive learners, it's for active learners. So try really hard to write the code and get engaged if you can. So just as a reminder, there's two ways you can run code. You can either highlight the code you want to run and then hit the run button at the top where it says run. So I'm moving my mouse over it. The more common way that people run code is they highlight the code that they want to run, hold down Control and hit Enter. So this is going to be the keyboard command. So kind of like Control Z copies and Control V paste in Microsoft Word, Control Enter runs your code. So I want to go over opening data again, but we're going to use different data tonight than we used last week. The reason I make a point to go over some things multiple times is these are things that if you can't open data, you can't run analysis. We're going to open data again. We're going to run some analysis again. So does anybody remember, starting with the questions here, does anybody remember if I just say data and I don't define the data right here, does that mean open up all of the data or open up none of the data? What does this mean? Will it show me all of the data or none of the data? So we have one person saying it's all, and okay, so we have a couple of people saying it's all. That's exactly right. Spoiler alert, it's given away right here where it says look at all data files. But I just wanted to make sure that people would actually participate so we can start asking some more in-depth questions. So I'm going to run this by highlighting it, holding down Control and hitting Enter. This opens up a new tab for us. This new tab is going to list all of the different data sets that we can work with that are built into R. So most people, when they're learning R, they learn it by using the different data sets that are already built into the package. So these are data sets that are already here. So I'm going to slowly scroll so you can kind of see the different exist. Last week we used the states data and we used the Ginsburg data. The Ginsburg data is about mental health, and the states data is about states, profits, and things like that. Tonight we're going to use some different data, so you can kind of see these. We're going to use some different data, and you're going to pull in other data for your own analysis. So I really want you to get into the practice of looking at these data sets and using them for your own work. So you see that open up a new tab that says our data set. So I'm going to go back to Untitled 1, which is our script 5. And decided that I want to use the database called Attitude. So I'm going to click on line 50. That'll highlight line 50. So I can either click on the 50 or I can click and drag. I personally like to click the numbers because it's less work. Hold down Control and hit Enter. And you'll see here that has come into the promise. So what that means is the data command says, I want to pull a spot for this database called Attitude. Now y'all may have noticed that I clicked on this little icon and it made it come up. So if you click it and it's large, and it shows like this, it'll open it up. This big one will make it the full window. So I don't want to do that. I just want to open it a little bit. But y'all see where it says Attitude and Promise. So that pulls the data. And then when I clicked on it, it forced it to open. So that's clicking on it does the exact same thing as this force command. So I'm going to go ahead and run this force command. Hold down Control and hit Enter. And the force command does two things. It makes the data open in the global environment. We see that we have 30 observations, which means we have 30 cases. They may be respondents, they may be companies, they may be states, but we have 30 observations. We have 7 different variables. So down here, I'm going to, you can move any box. So I'm going to make this bigger. I'm going to scroll up. And we see that we have our different variable names. So rating, complaints, privileges, learning, raises, critical, and advanced. Different variables. Each column represents a different variable. And each row is going to be a different observation. So this is observation 1 in line 1, observation 2 in line 2, observation 3 in line 3. So this 43 right here is the variable for the person in 1. So this is the first person's value on rating. And then the first person's value on complaints. Then the third person's value on privileges. So the cells align with the columns and the rows. So I just want to see if this makes sense to people. In the chat, can you tell me which observation does the 67 belong to and which variable does the 67 belong to? So which observation and then which variable? So it is the complaints variable and it is observation 7. Exactly. So we can see the data over here. All the individual data points are listed out in a very clear database frame. It looks like a traditional data frame for us. And then I can click this down arrow. I'm up here in the global environment, and I can click this down arrow, and it shows me a list of the 7 different variables. So these variables, you'll notice, are in the same order as the columns. So this is not by chance. This is not random. This is intentional. The first variable is the first column. Second variable is the second column, so on and so forth. Following that, you see that they all say NUM. This is because all of these variables are numeric, which means that the respondents' answers or the observations' answers are in numbers. And then immediately following that, you see there are different numbers following the variable. So this 43 right here should sound familiar. We talked about 43 explicitly earlier. So 43 right here is rating. It's the first value. If I go back down here, to rating, we see that the first value is 43. The second value is 63, and so 43, 63, 71. Over here, we see 43, I'm up here in the global environment, are 43, 63, and 71. So this tells me that these are not random numbers in that variable, but they are the ordered numbers in that variable. So these are two different ways that you can check to make sure that the data opened correctly. If you already have the data open and you just want to show your data, so this is something that's new. I don't think we did this last week. If you already have a database open and you want to look at the data in the format that we see down here, you can use the code show. So the difference between force and show is very simple. Force forces the data open. Show shows data that you've already opened. So force forces the data open, and show shows data you already have open. So I'm going to highlight this, hold down Control and hit Enter. And you'll see that we have the same output, show attitude, down here in the console. That's simply because we just want to show the data. Now, can somebody tell me a reason in the chat, why would you not want to show all of your data? What's a potential problem with showing all of your data? Do you think of any reason that this might cause issues or might not be effective? Yeah, so somebody said it may be too much or it may be an overload. Exactly. So this only has 30 observations, so it's not a whole lot of data lines to look at. Yeah, if you somebody said it may make your computer crash, so that's very potential. So if you're somebody like Jeremy and I are working on a really cool study right now of Twitter data, and we have tons and tons of data lines, and it's not really, doesn't really make sense to look at that many data lines to check it. So if you want to just look at the first 6 rows of data, you can use this code called head. So head is going to show the header of your data. So head attitude says, I want to show the head, which is the top part of the data attitude. So I'm going to highlight this, hold down Control and hit Enter. And you'll see that this only lists out the first 6 observations, so the first 6 people. This is nice because it's a very small table. It's very workable. You can see what the different variables are. You can make sure that it looks like they're formatted correctly. So let's say that you knew that all of your variables should be numeric, but when you open up the data and you look at the head of the data, you have all of these different words in here. Like what if it said male, female, 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 and you look at the variable and it says privileges. As a researcher, that would make me question, why would a variable called privileges be coded as male or female? So this is a good way to check your data. A very common issue I see when I work with people who are new to a program is they don't check their data when they open it. So you should always check your data. The head is how you show the first 6 rows of your data, and tail is how you show the last 6 rows of your data. So I'm going to highlight line 60, hold down Control and hit Enter. And looking at this tail, you'll notice that the numbers are 25, 26, 27, 28, 29, and 30 right here on the output. Does anybody have any idea why are these numbers showing and not 1, 2, 3, 4, 5, and 6? So why would 25 through 30 show versus 1 through 6 show? So any ideas on why this would say 25 through 30, not 1 through 6? So it's 6 rows from the bottom. This is correct. So why do the numbers go 25 through 30 if it's the 6 rows from the bottom? Like, why is the last number 30 and not 50 or 500 or 25,000? Why does it end in 30? Exactly. 30 observations. That's the end of the data. You're absolutely right. So this tells me that you're understanding that the different components. There's 30 observations. This is the end of the data, and that's why it's 25 through 30. So I show you this for multiple reasons, and one of the reasons is so that you can check to make sure that all of your data points loaded. So So if I'm doing an analysis and I know that my database should have 3,000 people in it, if I run the tail and it only goes to 30, I know that I'm missing a ton of my data. So you want to run not just the head, but also the tail to make sure that the variables loaded correctly at the beginning and they loaded correctly at the end. Now, there's not a guarantee that if the first 6 rows and the last 6 rows are right, that the rest of the data is right. But there's a good chance that if it starts correct and it ends correct, that the data is correct. So this is kind of one of my like little smell tests, if you will, that I put into all of the programs or all of my code to make sure that my data is opening. So the next thing is sometimes we don't want to look at datum points at all, right? We just want to know what kind of variables do I have and what are the variable names. So to do that, you run str. So str will show you the variable names and the type of variables that we have. So I'm going to highlight line 63, hold down Control and Enter. And you'll see down here that it says the data frame is 30 observations of 7 variables. And then you'll notice that this right here is almost identical to our global environment up here. Can anybody tell me what's the difference between the two? There's something distinctly different about the global environment up here and then this output down here in our console. Anybody notice what it is? There's something different. Yeah, so the $sign. Does anybody remember what does the $sign do in R? So in R, what do we use the $sign for? So the $sign is how we pick down the next level. So some people call this lock or locking, but yeah. So you would say from the database blank, and then you put a $sign to select the variable after that. So what this is saying that I think is kind of brilliant is it's saying from the database attitude for the individual variable rating, here's the information. For the individual variable complaints, here's the information. So it's a kind of a drill down function. Now I know that the $sign everybody associates with money, but I think of it in R as a drill bit. So like imagine the middle is the drill and the S is it turning. That helps you think about it's a drill down. So in the database attitude, I want to drill down specifically to the variable rating. If you've ever worked with me, you know I have lots of weird sayings and I have lots of weird things of remembering it, but that's how I remember this. So that's how you show the different variable information, and it's the same as the global environment. The reason you may be saying to yourself, yes, why would I ever run this? This is now in your output. So if you take your output and you share it with someone else or you look at it in a different format, you don't have this global environment later in your output, but you do have this in your output. So it's a nice way to kind of write that global environment information into your output. And the next is going to be show variable names. So if you want to show the variable names and the types of variables, so this numeric component, it's str. But if you just want to show the variable names, you just want a list of the variable names, the code is names and then database name. So names attitude. I'm going to highlight this, hold down Control and hit Enter. And you'll notice that it lists the variable names out for me. This is something that I use quite a bit in R when I have a new database because I'll run the names. Let me see all of the different variable names. So there's some relative universals in databases. Things like sex usually means male or female. Age usually means how old someone is. Income is usually either a dollar amount or a group. So I like to look at all of the variable names to kind of see what do I have beyond my main dependent variable or a variable of interest to see different things, especially things like control variables. So do y'all have any questions about anything about opening data? How to find databases built into R, how to open the database, how to look at the database, how to show the head of the database, the tail of the database, information, or variable names. Any questions about any of those things? So a question came in saying, could you repeat the show versus force? Absolutely. So the show right here, this is what you use when you've already opened data. So if you already have data open in your global environment and you want to show it as a data frame, so I'm going to hit Control Enter so you can see. You'll see that it produces this table for you. All that show does is produce this table. What force does is it actually reopens the data or opens the data for the first time. And the force function, the output of the table. So if I say force attitude, that will open up the database attitude. That'll show up here in the global environment. And then it will also produce this table down here. Show, the code show only generates this output. So the difference between force and show is force forces the data open and show simply shows the data. Does that make sense? Cool, cool, cool. Any other questions? That's a good one. That's a really good one. Okay, can I run the command head before I open the database? Can I run the command head before I open the database? What do you think? No. So y'all are saying no. Why not? Why can I not show data, show the head of the data if I don't have the data open? Why can I not show the first 6 lines of data before I have the data open? And the answer is really simple, and you hit the nail on the head. Somebody said there's no data yet. Another person said there's nothing to pull from. So you want to make sure that you open your data, then show your data. So open data, show data. So the next thing I want to do is I want to run through some basic statistics again. This is for 2 purposes. One, to remind you how to run some basic statistics. And the other thing is to remind you of some of the code patterns that we talked about last week. So this is the running the analysis mean. Mean is the mathematical average from the database attitude for the variable rating. So this is saying I want the average of the variable rating, and the variable rating is housed in the database attitude. So I'm going to highlight this, hold down Control and hit Enter, and it produces our outcome right here. So the average value of someone for rating is 64.63333. So can somebody tell me, never mind, I already told you. Okay, so the next thing is median. So median is very simple. It's simply median, attitude, database, variable, rating. Now, you're probably sitting there and saying to yourself, why do I have to say the database name if we only have one database open? Is anybody like kind of wondering that? Like, so if I only have one database open, why do I have to say the database name? The truth is you don't have to. If you have one database open, you could just run the code and say median rating. The reason that I teach y'all the attitude $ rating is so that you can get a good habit of it. Every R user I know who uses R at a higher level almost always has multiple database open at one time. So it's a good practice to go ahead and learn for yourself. So we have median, attitude, rating. I'm going to highlight this, hold down Control and hit Enter. And you'll see that our median is 65.5. So our mean and our median are pretty close. So a question came in, can I use the $ when I open the data in the file? So when you open the data, you need to open the entire database, and then you can look at the individual variable, like Excel file. I don't think I understand your question. Can you ask it? And so I use the $ when I open data in a file like an Excel file. Are you saying like you can in Excel, or can you open an Excel file in R? Oh, okay. So George is saying you can import the data from Excel to R and then use the $ to draw variables. So if you have a data file from any other program, once it's in R, you can use the $ to lock in on it. But if you want to open a data file, you have to import the data or open the data in R and then use the drill down. So you don't, out of the gate, you don't say open data only this variable. What you would need to do is open the entire data file, and then if you wanted to delete variables you're not using, do it from there. So you want to open the data, then use the drill down. Cool. Thank you, George. So then we have our standard deviation coding. So standard deviation is standard deviation, attitude, and rating. If you would like, we have more information on this in R1, so check that out. Highlight this, hold down Control and hit Enter, and we get our standard deviation right here. So you'll notice that R gives a large amount of decimal points compared to other programs. The only other program that I use that gives this many decimal points is SAS. Most data programs give 3 decimal points, and R gives quite a bit more. This is largely because R was designed initially for programmers, and programmers largely use tons and tons of decimal points. Just because there are more decimal points doesn't mean that other packages are incorrect or better or worse. It's just a different standard across the package. The next one is IQR. So IQR is the interquartile range. I'll type that right here. Interquartile range is the range between the 25th percentile and the 75th percentile. I'm going to highlight this. I'm going to run an IQR for the database attitude, variable rating, hold down Control and hit Enter. And you'll notice here that the value is 13. So I mentioned this last workshop, but I want to mention it again. For the IQR, the interquartile range, it gives you the calculated IQR. It does not give you the values. So every other statistical package, every other statistical program I work in actually gives you the 25th percentile value and the 75th percentile value. R does not do that. If you ask it for IQR, it calculates the range. So last week we talked about you can request quintiles, and the code for the quintiles will allow you to identify the 25th and 75th percentile if you'd like. And then the last one is the correlation coefficient. The correlation coefficient is just COR. Can anybody tell me why are there 2 variables here, not 1 variable? Every other statistic we've run has had 1 variable. Why would the correlation coefficient have 2 variables? Why would a correlation coefficient have 2 variables, but the IQR has 1 variable? Somebody said strong and weak. Any agreeing or rebuttals about why would we have 2 variables in a correlation coefficient?
Because we are looking for 2 variables and the correlation of them.
Yeah, so the correlation coefficient is looking at the relationship between multiple variables. You cannot correlate a variable with itself. If you do, it's a 1. So if I want to predict your age and I know how old you are, I can predict that with 100% accuracy. Remember that correlation coefficient is a correlation between 2 or more variables. So we have to identify more than 1 variable. So this is an important thing to remember. If you're running a statistic that requires multiple variables, make sure you identify all of the variables that you're interested in doing. So I'm going to highlight this, Control and hit Enter, and it'll produce the correlation coefficient between the 2 variables. So we see that rating and complaints has a strong positive relationship. Correlation coefficients range from 1, the closer to 1, the stronger they are. 1 is basically non-existent, and 0 usually isn't existent either. So we range from 0 to 1. The closer to 1, the stronger it is. 0.82 by everyone's standards that I know of is considered strong. The reason that it's positive is because this number is positive. So if the number was negative, we would know that it's a negative correlation. Questions about these statistics? I covered just these basics. We cover a ton more in R1, but I want to get your brain back into coding mode for R, identifying databases and variables. Y'all have any questions about these statistics that we have run? If they come up, just put them in the chat. Y'all notice that George and Jeremy are all questions in the chat as well. Okay, this next section that we're going to do, new variables. I would argue that this is the most important skill from this workshop. So please take notes, either literal or mental notes on these different things. I think that people get a lot out of the workshops if they think, I can use that in my study this way, or I could use that in a future way. So be selfish, think about your own work in context of this. I think it'll help be a bit more salient. So if we want to make a variable with a constant value, so a variable that single person has the same value, the code is very, very simple. It's the new variable name, and then an arrow, whatever you want it to be equal to. So here we're making a variable called wave1, and we're making everyone equal to a 1. So I want to talk about why you would ever do this. So the biggest this is with my longitudinal analysis. If you're not a person who knows what that means, longitudinal analysis is when you study people over time. So I have the most is a 3-wave study. So I have people in 2010, no, not 2010, let's say 2010, let's just make it easy. People in 2010, people in 2015, and then people in 2020. So if I have 3 different databases and I want to merge those databases, I would need to identify in each database which wave they're from. So open the wave 1 database, make this variable, the wave 1 is equal to 1, then open the wave 2 data, and then make a variable called wave 2, and then in the wave 3 data, make a variable called wave 3. The reason that we do this is so that we can identify, once we merge our data files together, which database did the variable come from. So which database did the variable and the respondent come from? If you have panel data, that means you have the same people over time, and that makes this even more important because you want to know not what was their value just at the end, but maybe at a midpoint and at the beginning of your study. So people who use these constant value variables a lot are psychologists and nurses in pre-post test analysis, people in business when they have a different database on different companies. So let's say you have one database on IBM, you have another database on Apple, and you want to merge those two together. You may have an identifier for Apple and an identifier for IBM, I think is what I said. So this is going to be people who work with multiple data sets, but you need to identify which data set the variable or the respondent came from. So we're going to do wave 1 is equal to a 1. Now you can replace this arrow with an equal sign. It will work the same. I personally like the arrows because it helps me identify I'm taking what's on the right, and that is feeding into this variable that I'm making. So let me highlight this, hold down Control and hit Enter. And you'll notice down over here, sorry, that a new area started called values. And then we have wave 1. You see this? This variable, we did not put it in the database. We put it separately than the database. We made it into a value. So wave 1. Does anybody remember what the show function does? We talked about it kind of ad nauseum earlier. What does show do? I say show wave 1. What will this do for us? Any ideas? What will show do? It'll just show the variable and it'll give you the value that you assigned. Exactly. I'm going to highlight this, hold down Control and hit Enter. But only one value showed up. So before, when we showed variables, it showed us all of their values. The reason that only one value is showing up is because we didn't put it in the database. So you can also make values or constants in R by using this function. So this is saying I want to make a variable called wave 1 and make it everyone equal to a 1. Well, because it's a value and it didn't get put in the database, it only has a value here. Okay. So I want to show you how to do some things beyond just making a constant. The first one is, well, actually, let's back up. How do you think I could edit this if I wanted to copy? So I'm going to put on the screen what I want you to do. So make a variable that is equal to the variable rating. So in the chat, paste the code. We want to make a variable that is equal to the variable rating, and you can call it rate, just to make it easy. So make a variable that's equal to the variable rating, call it rate. I like how you all have the answer for it. So we want to make the variable called rate and make it based off of rating. So we put new variable name, then the arrow, then the old variable name. So it's going to be rate, arrow over rating. So it's easy to get these mixed up, but here's the code. Rate, rating. So it goes new variable name as defined by old variable name. The next thing that you may want to do beyond copying variables is do some basic math. It's really simple. So RTY, and RTY is generated by taking the data added to it. New variable is complete. So I'm going to highlight this, hold down Control, hit Enter, and you'll see down here under the values it was produced. I'm going to show you in a little bit how to make a variable that ends up in the data frame, so don't worry about that, but it'll come up. So you'll see RTY here is a numeric variable, but this time it ranges from 1 to 30. So this means there's a value 1, and then it moves all the way through the variable 30, or the value 30. Why is it 30 and not just 1? Does anybody have any ideas? Why is it 30 and not just 1? Wave 1 was just a 1. Why is RTY 30 of them? Yeah, so there's 30 observations in the original database. Remember we said take this variable complaints and add 5 to it. Well, complaints right up here is from a database that has 30 observations. Sorry. Complaints right here has 30 observations. So when you make a new variable based on that variable, it's also going to have 30 observations. And so I'm going to say show RTY, control and hit enter. Now the show command is not required whenever you make a variable, but I strongly suggest you do it. It's your way of checking the variable. So down here you see 56. How could we check to make sure that this number is correct? Like anytime you make a variable, you should check it. So how could we check to see if 56 is the right number for this variable? The variable, just as a reminder, was generated by taking complaint 5 to it. So how could we check to see if this variable is correct at 56? Any ideas on how we could check this variable? So somebody says check again through the global environment. Okay, so let's go down this rabbit hole for a minute. So this is the variable complaints. Here's our variable complaints up here under the global environment. And the first one, its value is 51. So 51 plus 5 is 56. So 51 up here, and the formula is to say complaints plus 5. So 51 plus 5 is 56. You can also show the two variables next to each other. So we have show RTY. So I'm going to say show attitude complaints. And now we see the variables kind of stacked on top of each other. So this was suggested in the chat. I'm just saying that for the recording, and later y'all are like, what is she talking about? But you see that these are 56, 56, and 51, the difference is 5. 69 and 64, the difference is 5. 75 and 70, it's 65. So we can see that the variable is made correctly. So it's really important to compare your variables and they're calculated correctly. So beyond being able to add a specific value to a variable, you can also add variables to each other. So let's say that we want to make a variable called RTYU and make that variable a product of complaints plus learning. So you say, I want to add the variable complaint and the valuable learning together. So I'm going to highlight that, control and hit enter, and you'll see that variable is generated in the values box. And then we can show it. This will produce an output of the variable below. And we see here 90, 118, 139, 110, 144, so on and so forth. So just like before, when we said, I want to show that individual variable, we could check by showing complaints and learning and then manually add them together. Y'all notice how this number is 1 and then this number is 26. So down here in the console, we have a 1 and we have a 26. So keep in mind those numbers. I'm going to scooch this over and I'm going to run the show command again. Okay? Now the number is 1 and 17. So 1 and 17. What these numbers are indicating to us is which case immediately follows. So the first number in that row, what case is it? So the first one's always going to be 1 if you ask for to show the data. So that means that the first case is 90. That's the value for the first case. And then the 17th case is value 154. And the reason this is a 26 is, remember, the line was longer, so 140 is case 26. I'm going to stretch this back out and so I can show you by counting them. So this one says 17, case 17 is 154. So I'm going to go up to this top one. This is case 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 15, 16, and then 17. 154, that's the 17th one I counted over. And it says 17 right before 154. So in R, and this is not a function, it's anytime that you have data points that are wrapping, it'll tell you the number of immediately following that number. Okay, so that's how to add variables together. Subtraction is very simple. It is the opposite of adding, you subtract. So you can make a variable. Here we're going to make a variable called QUE, and that will be generated by taking the and subtracting 5. So before we took complaints and added 5, and now we're going to take complaints and subtract 5. I'm going to highlight 110, hold down Control and hit Enter. And you'll see that it generates the variable over here in the values and the global environment, just like before. I'm going to run the show command. And this will show us the 30 observations. And we could do this by saying, show me from the database attitude complaints. I'm going to highlight this, hold Control and hit Enter, and we can compare the two lines, right? Minus 5 is 46, 64 minus 5 is 59. So we know that the variable is created correctly. So just like we can subtract a number or a constant from a variable, we can also subtract a variable from another variable. So here we're making the variable QUER, and it is defined as the variable complaints minus the variable learning. If you're struggling to think of examples of why you would use this, let's say that you're an economist and you want to know somebody's net worth. You may take their assets and then subtract their debts. And this will tell you how much more money they have in assets than they have in debts. You may also say, I want to take somebody's total score and subtract the points that were earned on a certain assignment to see what their score would have been if they didn't do that assignment. So it's truly just you have a theoretical reason for generating that variable, and this is the function to do it. So I'm going to highlight this, hold down Control and hit Enter. Again, you see QUER is populated in here, and it goes from there. You can show QUER, it'll give us the values here. I want to go back to this value column for just a minute. In almost every statistical program, when you make a new variable, that variable is put at the end of the database. Does anybody notice with values that they haven't been going in the order that we generate them? What are the values populated in this area right here? So it's not generated in the order that they were made. It's generated in a different order. What's the order for the values? Yeah, it's alphabetically. So it just puts them in alphabetical order for you. This is something that I actually really struggled with, and I thought I wasn't making variables, and I kept making them over and over because I was so used to them populating at the end. And so this was a little thing that kind of threw me for a loop when I first started learning R, so I wanted to point it out. Okay, the next thing, and this is actually something that people mess up a lot on. When you do multiplication, you'll say, this is my new variable name, and that variable is generated by taking the variable complaints and multiplying it by 100. Now, do y'all see that this is not an X, it is a star. So it's made by the star over your number 8. I cannot tell you how many times people have come to me and said their code was broken because they had this. So we are largely trained that X means multiply. In R, X does not mean multiply. So make sure that you use the star. So we're going to make it ASD and make it generated by taking the variable complaints and multiplying it by 100. So I'm going to highlight this, hold down Control and hit Enter. And it adds in our ASD. And as y'all mentioned, they're in alphabetical order, so it pops up right here at the top. And we can show those values for ASD. And we see that ASD is just the variable complaints. I'm going to run a show so you can see this. Attitude. And it's just each of these values with 2 more zeros because it's a value multiplied by 100. Can any of y'all tell me what is a common time that we take a value and multiply it by 100? We do this all the time in statistics. When do we take a value and multiply it by 100? Does anybody have any ideas? Why would we take a value and multiply it by 100? Exactly. So somebody said to get a percentage. So to go from a proportion to a percent, we multiply it by 100. So this is like since the dawn of statistics, if you will, we've been using this multiply by 100. Okay, great. So that's multiplication. And then if you want to multiply one variable by another variable, we have our outcome variable, which is ASDF. I hope y'all are really appreciating these great variable names. I'm glad somebody laughed at my dawn of math. Thank you so much. I make some comments. People just ignore them. So thank you for the nod. The ASDF is the new variable name, and it's generated by the variable complaints times the variable learning. So I'm going to highlight this, hold down Control and hit Enter. And this is going to be the variable complaints times the variable learning. And then I can show this variable. So I want to pause here just for a moment. Is anybody a social scientist? So a sociologist, a psychologist, an anthropologist, we'll take anybody. Is anybody a social scientist that's here? We have a political scientist. Do we have any other, political science is a social science, absolutely. Is there any other social scientist in the room? No, wow, it's lonely. Okay, so I'm a sociologist by training, and I use multiplying variables by each other all the time. And we in the social sciences use these for a thing called interaction. So an interaction variable is when we talk about, we want to know about Black women, or we want to know about college educated mothers. And so what we do is we multiply two variables by each other, and the product of that variable is our group. So if I have a variable that identifies people who are Black, and I have a variable that identifies people who are women, if I put those variables together, I can identify people who are Black women. So I am really interested in older adults with disabilities. So I use this all the time. So instead of saying attitude complaints, I may have a variable that identifies who has a disability and then who is an older adult. And by putting those variables together, if those variables are a 0, 1, who's an older adult with a disability. So that's something that I multiply by itself quite a bit. I also know that people, when they want to predict how much money they'll spend long term with a certain interest rate, they'll take the base cost and then multiply it by an interest rate and then do that over and over. So the reason I'm pausing here and telling you this is at this point in the workshop and you're seeing all these different variables being generated, it may be easy to kind of like glaze over and not think about how you would use it. So I wanted to pull you back in and make sure that you're seeing how you might. So that's how you do a variable by another variable. Division is just a backslash. So generate a variable called EST, and it's generated by variable complaints and dividing it by 100. So I want to take and divide it by 100. So earlier we talked about you can go from a proportion to multiplying by 100. Maybe you have a percent and you want to convert it to a proportion, so you would divide it by 100. That's how this variable is generated. And I'll hit enter, and that generates our variable over here, EST. And then we can show EST below, and it has been produced for us. Then you can also divide a variable by a variable. So happy is the first real variable name. Happy is produced by the number of that someone has divided by their learning. So complaints divided by generates happiness. So I'm going to highlight this, hold down Control and you'll see that happy is produced right here. And then I can say show happy, and that shows my variable for me. Okay, so this is going to be kind of the basic math, adding, subtracting, multiplying, and dividing. So what I want you to do as a practice question, I'm just going to paste it in here. I want you to generate a variable that is complaints times learning. Can you make this variable for me? So sorry, let me say generate a variable ASDS, that is complaints times learning. So take a second and write this code and then put it in the chat. No judgment, worst case you're wrong, right? Like I'm only on one of your committees. I'm not your professor. I don't think any of you. So type it in there for me. So how would you make the variable ASDS, that is complaints times learning? Oh, dang, look at you. You came in hot. That's right. There's a little bit of spelling issues, but this code is correct. So ASDS is attitude complaints by attitude learning. Great. Great. Tons of people have it. So 1%, the reason I'm not saying names is you haven't given me consent and I'm recording this. So that's why I'm not saying anybody's names except for George and Jeremy because they're colleagues of mine. But do y'all see in the chat how one person put an equal sign? That's also correct. So the equal sign or the arrow are both right. They produce the same outcome. So great job on that. I'm going to copy one over and paste it just so for the recording when somebody wants to look at it, this is correct. So we see it's ASDS is generated by database attitude variable complaints times database attitude variable learning. So nice job. So the next thing that we're going to do, well, let's pause here. Does anybody have questions about adding, subtracting, dividing variables in R? Do we have any questions about adding, subtracting, multiplying, or dividing variables in R? I'm going to answer a question that somebody asked the last time I taught R while y'all are typing in questions if you have them. And somebody asked, can you multiply and divide? Can you do like multiple data steps in one line of code? You can, but you want to make sure that you use heavy use of parentheses. So let's say that you wanted to make this variable ASDS of complaints times learning divided by raises. So you wouldn't put divided by attitude raises. You wouldn't put that alone. You would put these parentheses in to make sure that the order in which you want the analysis done is completed. So I have a tendency to heavily use parentheses, even if I think the program will do it correctly, just to make sure that what I'm is generated. A notable amount of coding questions I get is from people not adding parentheses ineffectively, parentheses or brackets in. I didn't see any other questions come in. Please feel free, if you're still typing, just keep typing, and either I, Jeremy, or George will answer your question. Or we'll tell you we don't know. That's also an option. Okay. So the next thing that we're going to do is we're going to split variables. So dust off your pencils. Let's do something here. What we want to do is we want to split the variable into a high and low. So we're going to take this and we're going to convert a numeric variable into a classified of a high or low. So if you have never done an if-else statement, follow along with me just for a moment. I want to explain how they work and then we'll do the code. If-else statements work like this. You tell the program, if a condition is met, give it a specific value. So let's do, since we're kind of in a transitional season of spring. If the season is spring, code the variable as a 1. Else, so if it's not spring, code it as a 0. So what that'll do is it'll produce a dichotomous variable or a 2-value variable where spring is equal to 1 and not spring is equal to 0. So we use if-else statements all the time in research. And so what you do is you give a conditional statement or a qualifier for the if. And if the value doesn't hit that criteria, it's classified as an else. So either you're spring or you're not spring. And so here in our code, we're going to use we're going to use high and low. So let me walk through this. We're going to make, in the database attitude, a variable rating 2. So when you make a variable, let's pause here for a minute. When you want to put a variable in the original database, this is how you do it. So if you, I'm going to say that again. If you want to put a variable in the database, this is how you do it. Saying, within the database attitude, make a variable and call it rating 2. So in the database attitude, make a variable called rating 2. Now you need to make sure that this variable name is different than any variables in that database because it will override it. So make sure it's a different name because it will override it. So in the database attitude, make a variable called rating 2. Define it with an if-else statement. So if-else and if-then are the same thing. So this is the if statement. If the database attitude variable rating is greater than 50, classify it as a high. And then remember earlier I said it's an if-then or if-else. If it is not a high, then classify it as low. So basically what we're doing is we're taking this variable rating and we're splitting it 50. If it's greater than 50, make it high. If it's lower than 50, make it a low. So I'm going to go through this code again. In the database attitude, make a variable called rating 2. Define that variable using an if-else statement. If the database attitude variable rating is greater than 50, then classify that variable as high. And then remember, if else says if that is met, and then everybody else is in a different classification. And we have else it is low. So I was talking with George about this earlier. Something that's really hard about teaching in this format is I can't see your faces. So if we were like in a classroom, I could look at you and tell if you understand this. So in the chat, can you type on a scale of 1 to 5, 5 being it's completely clear I understand it, and 1 being I need you to start over from square one. Like kind of where are you? 5 is I completely understand, and 1 start over. Okay, so we got some 5s and some 4s. That's all I ask. Okay, is anybody a 3 or below? There's no judgment. I'm just asking questions. Okay, cool. Y'all are 5s mostly. 4s, thank you for being honest. We're in the same boat. I normally feel like a 4. So one more time. In the database attitude, make a variable called rating 2. Generate that variable using an if-else statement. So if the database attitude variable rating is greater than 50, classify the variable as high. Otherwise, classify it as low. I'm going to highlight this and run it. Control Enter. And now, do y'all see up here where it says rating 2? The variable was put into the original database because we said to put it in there. And now I'm going to show the original variable, which is attitude rating, and the new variable attitude rating 2. So Control Enter, and we'll see 43, 61, 61, 81, right? And then I'm going to say show database attitude variable rating 2. Highlight this, hold down Control and hit Enter. And now we see low, high, 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 low, high, high, all of this, right? So these should match. 43 is less than 50, or 50 or less, so it's a low. 63 is greater than 50, so it's a high. 71 is greater than 50, so it's a high. And we could rinse and repeat all the way through, check all of the values. So this is helpful in 2 ways. The first way is now you know how to split a variable using an if-then statement. The other thing that you have just learned is how to convert a variable from numeric to words. So R is really powerful in the sense that you can analyze the words. It'll tell you a count of them and things like that. This is not possible in other programs. So in Stata, SAS, and SPSS, the data will not work if it's words. It can only list them, but in R, you can generate these variables very easily. And that's a big drive of people wanting to know how to do R. If you're a Python user like Jeremy, you've known this. This is old news to you. Python also has this capacity, but this is something that is very different compared to the other programs that I use. So that we're going to come back to this. So our 4s, we're going to get you to 5s by the end of the workshop. Okay? And the next thing you may be asking yourself is, but I don't want 2 categories. I want 3 or 5 or 10 or 50. So I want to show you how to split variables into multiple categories beyond 2. So if you're going to use 3 or more categories, you can't use an if-else statement, because if-else, there's an if and there's an else, which is 2. So if you need more than 2, you have to do these statements. So do me a favor, just stick the line of code that I am, and we'll come back and talk about them together. So in the database attitude, make a variable called rating 3. So just like before, we made a variable called rating 2. This is a variable called rating 3. The reason these variables actually have names that mean something. Rating 2 is rating broken into 2 groups, and rating 3 is breaking rating into 3 groups. So this is saying take the variable attitude, database attitude variable rating, and if it is greater than or equal to 75, then define it as upper 25. So let me say that one more time. In the database attitude, make a variable called rating 3. If in the database attitude, the variable rating is greater than or equal to 75, then make the value upper 25. Now, y'all, or else you wouldn't be here. You'll notice that this arrow is not where we normally have the arrow. The arrow is normally right next to that variable here. this is something you want to note, and you want to remember that the arrow is shifted over when you're making multiple categories. So I'm going to run just this first line of code right here. And that's going to generate that variable for us. But then I'm going to show the variable because I want you to see this as we progress through. I'm going to show attitude variable rating 3. And y'all will notice that there's all of these NAs in here. And then there's some upper 25s. What do you think these NAs are? NAs, what do you think those are right there? Where they say NA. What do you think NA is? We didn't define those cases. Not determined. Wow, y'all are really smart. Yeah, that's exactly right. So NA means that there's no answer. So a kind of like thing between George and I, whenever there's missing data, we always go nah. And that's because that's what R calls them. So this means that the data hasn't been defined yet. So let's keep moving through so that we can address that. So somebody asked, can we drop the NAs? We can, but let's wait and see if we can define them first. But you can drop whatever you want. Yeah. I like how George came in. George is all about drop and missing, so he can show you how to do that. So the next line of code we're going to run is in the database attitude, make the variable rating 3. And if in the database attitude, the variable rating is greater than 25 and that variable, database attitude variable rating is less than 75, then define it as the middle 50. So this is using several things. The first one is it's generating a new component, the middle 50, but it's also using multiple conditions. So this is saying the variable has to be bigger than 25 and it has to be less than 75. So this is some pretty complex code, and you'll notice that it doesn't say AND. It shows the thing that looks like a little person to me. So it's ampersand, I think is how you say this. I'm not sure just to say that out loud, but I think that's what it's called. And then that group is defined as the middle 50. So to say this code again, in the database attitude, make a variable called rating 3. In the database attitude, the variable rating, if it's greater than 25, and if in the variable rating is less than 75, then define this as the middle 50. So I'm going to highlight this, hold down Control and hit Enter. And that's going to edit that. And then I'm going to run this show again so you can see how the variable was changed. And now you'll see how many NAs left because those NAs were actually all middle 50s. But I want to make sure that you can see the code for the sake of being able to see the code. So in the database attitude, make a variable called rating 3. In the database attitude, if the variable rating is less than or equal to 25, then define it as lower 25. So I'm going to highlight this, hold down Control and hit Enter. Now, this actually isn't going to change our variable because that are this low, but I just wanted you to have code so you can see multiple categories and how they work. And then I can run this last one so you can see the variable. I want to point out a couple of things in this code. The first one is if you are a person, most people learn R as a second language. I mentioned that last week. So a second program. The difference is when you're making it R, you don't have to use a replace function and you don't have to use all these different things. You actually overwrite the original variable. So here we see in the database attitude, make a variable called rating 3, and then we have an upper 25%. And then in the database attitude, make a variable called rating 3, and then there's a middle 50. And in the database attitude rating 3, make a lower 25. So what you're not having to write replace functions, you actually can override the variable very, very easily. This is good and bad.
Mira, lo que te pasa, te pone así.
You're not muted. So let's talk about good first. The good part is you don't have to learn a bunch of replace functions and you don't have to constantly be clearing out variables when there's an issue. The con is more than a couple of people have overwrote their data not realizing that they did it. So make sure, because R assumes that you know what you're doing when you're making variables, make sure that you're writing something else. So this is an important thing to know. Do y'all have any questions about the if-then statement or if-else statement, and then the 3 or more categories option? Any questions about splitting? Some people call these binning or collapsing. The question is it how we recode continuous variables like age to group them? Absolutely. So if you wanted to group age, you may say, let's say that we have people's ages and those people range from 10 to 40. So we would probably put people 10 to 17 in a group together because they're minors. And then they put people 18 to 25 together if you're a health researcher and you're studying from like a life course perspective, because that's a period called emerging adulthood. So you can collapse or bin, or you can do whatever you want for this. Different disciplines call it different things. That's why I'm calling it all these different things. Okay, what we're going to do is we're going to do a couple of practice questions, and then we're going to move on. There's tons and tons of practice questions built into this workshop because I want to make sure that you have some practice coding. So here's our first practice set. I'm going to, at each minute, add in the code. So actually, let's do this. As soon as somebody gets it right in the chat, I'll add the code in here. So here's the things that you're going to do. The first one is open the data chick weight, then show the data chick weight, generate a variable that is called weight times time, and then all of these variables are in that chick weight data set. So as soon as somebody gets it right in the code, I'll paste it into this. Okay? So just work your way through. Okay? Okay, so we have the data, and then we have the force. Okay, how do I show? Okay, how do I show? Show's already there. Scooch this down a little bit. How do I generate a variable called wait time? That is wait times time. Now, wait and time are variables in chick weight. How would I generate a variable called wait time? That is wait times time in chick weight. It's a bit more of a complicated question. So we want to generate a variable called, the reason I keep talking is people think that their WebEx crashed if I don't. So we're saying we want to make a variable called wait time. That is wait times time. Great. So we actually have 2 people in the chat who typed this in. Both of them are correct. So I'm going to say chick weight variable called wait time is defined as chick weight to wait times chick weight times time. Oh, sorry, not $sign. Yeah, time. Did y'all see as I was typing the code how the different things were produced for me? Yeah. Okay, there are 2 ways that you can make this variable. That is wait 2. We have one of them that's in the chat. Somebody else tell me how to make it with another way. So there's 2 ways that you could do this. One of them is in the chat. What's another way that I could do this? Anybody have any other ideas of how we could make a variable in squares? Yeah. So we can do it one of 2 ways. We can either take it to the second power, which is line 165 on my screen, or we could just simply multiply it by itself, because remember we have the power to use these variables in different contexts. So we can multiply a variable by itself, or we could square it. That produces the exact same outcome. Okay, this is the hardest question. Generate a variable called weight. That above goal for weight is above 200. Technically 200 or higher. Goal is between 100 and 199, and below goal is for wait time is below 100. So what would the code for this be? I'm just writing this first part in so that we don't have to do it later. I wish I had Jeopardy music right now, or that I could sing well, so that you wouldn't be mad if I sang the Jeopardy song. We have these three that we're making. If you have one section of it and you want to paste it in the chat, you can do that too. There will be 3 lines of code. How do we make the WGTT variable? Okay, so we have one of them. There is a slight error in that code. It's very, very, well, it's relatively small. When you're making the 3 different classifications, you have to identify the database. I'm going to go ahead and I'm going to edit it, but note that there's a little bit of difference here. If you don't identify the database, it does not work when you're doing these classifications. Does anybody have, so when I type W in, does anybody have an idea why WGT time is not showing up? Any ideas? If you decide you just kind of want to watch on the code, does anybody have an idea why is that variable not showing up here? It's not added. Yeah, that's exactly right. You can't do something with a variable you didn't use. Earlier I asked y'all, could I show the head of data that I haven't opened? And that was intentional for this exact example because I knew that I wouldn't make the variables. So you have to make the variable before you can use the variable in another way. So I'm just going to type in the variable information here. So it's greater than or equal to 200, and that's going to be defined as above goal. Okay. Does anybody have the next line of code for us? Worst case, you're wrong. Okay, so we have above goal and we have, can I get a goal line of code? So I have the above goal and I have the below goal. I'm looking for the goal line of code. So does anybody have the goal line of code? Oh, awesome. This one is a bit more complicated, isn't it? So let's see what we have. So we're making a variable called WGTT. So I'm going to remove this extra. So WGTT, and then this arrow is also extra. Close though. This is tough. So it's not attitude, it's chick weight. And then we have WGG time. If it's greater than 100 and chick weight time is less than 199 goal, there is we have something missing. Does anybody notice the code is so close, but it's not quite there? We're missing something. Can anybody tell me from line 170, what are we missing? The equal sign, exactly. So remember, it's between 100 and 199. So we need to include 100 and 199. So we're going to say if it's greater than or equal to, or if it's less than, or yeah. So if it's greater than 100 or equal to 100, and if it's less than 199 or equal to 199. So you can do this is correct. If you want to do greater than or equal or greater than, the code works. So I want to let you know I'm super impressed. I was a little worried about doing these questions in the online format, but I think it worked out pretty good. So this is right. So it'll be on the recording. So if when you go to check and maybe do these practice questions on your own later, you'll have the code here for you to look at, okay? We're going to skip this second practice question. We might come back to it, but I want to make sure we get through all of the material for the workshop. So I intentionally build in 2 sets of practice questions. The first one that I try to get through in the workshop, and then the second one for you to practice on your own later once you go back through the workshop. Okay, so the next thing that we're going to do is linear regression. So for linear regression, the code is a little bit different than other programs. So what you do is you generate a model by name. So reg model is the name of the linear regression model. So I'm calling this model reg model. You could call it banana, chicken. It doesn't matter. You can name it whatever you want. I will tell y'all that in this workshop, it's called reg model, but in my own research, I do this. I call it like model 1, model 2, model 3, so that I know which model it is for my table later. But for the workshop, I'm calling it reg model because it's a regression model. Just as a reminder, regression is predicting a continuous or numerical outcome that is predicted on a line, and that's why it's called a linear regression. So I'm predicting a line of a dependent variable given an independent variable. So the code goes like this. The name of the model is equal to a linear model of the database attitude variable rating on the database attitude variable complaints. So I'm running a regression model on this outcome right here. So it goes, just to say it one more time, this is the name of the model is equal to the linear of the database attitude variable rating by database attitude variable complaints. So we're looking at the relationship between rating and complaints. You'll need that marker between the 2 variables to make a linear regression model. This should look familiar. We used this with our scatter plots last week. Okay, so let me highlight this, hold down Control and hit Enter. And you'll see that in the database over here, there's a reg model that's produced. So this is our model that we've made. We have this database of attitude at the top, and then we have a reg model down here. I'm going to click the down arrow, and you'll see that it gives me the coefficients, the residuals, the effects, the rank, fitted values, all of this different information in this little pocketed area. So this is nice, but it's not super helpful if you need to look at different factors or look at the actual model fit statistics. So I want to show you how to pull up different outcomes for this regression model. I'm going to put that back up, but note that it is produced in the global environment, and it's produced in the same area as the databases. So we're going to run just the results table for the model. So the code for this is summary reg model. So earlier, remember, summary and a variable name will produce the descriptive statistics for that variable. Summary reg model will produce the results table for the model. Hold down Control and hit Enter. I'm going to expand this up so that we can see it. So a question in the chat was, does it matter what order the variables are in? Absolutely, it matters, because we want to know the variable's importance. So it goes dependent variable and then independent variable. So George put it in the chat, DV and IV. So the residuals up here at the top, remember that residual is the error term, or the difference between our predicted value and actual value. So if I predicted you to have a 12 and you actually are a value of 10, you're be a 2 because we were off by 2. The residual is the measure of error. The error is the difference between the predicted value and the actual value. Following that, we see our coefficient table. Something that I want to note is it starts with the intercept. Most of the time, statistical packages put the intercept at the bottom. In R, the intercept is put at the top. So this is just something to make a mental note of. The first column is our estimate. That's followed by our standard error, followed by our t-value. You may know this as a t-score. And then this is our statistical significance. To the right of the statistical significance, you'll notice that there are stars here. So this is a really big appeal for people in R. It actually tells you which ones are statistically significant. So it follows a pretty standard naming nomenclature. So 1 star is 0.05. Oh, wow, that was weird. 0.05. 2 stars is 0.01. And 3 stars is 0.001. So because this 0.03 is less than 0.05, it has a 1 star next to it. So that's for our intercept. Your home discipline may not call it the intercept. That may call the beta naught, or it may be called the constant. But it's the baseline value that everyone starts with. So it's either in your discipline called an intercept, a beta naught, or a constant. And then this is the effect of the variable complaints on predicting the variable rating. So we see that this value is 0.75. It's a positive number. So we know there's a positive association between complaints and rating. So if somebody has a higher complaint score, that means they have a higher rating score. And for each 1 unit increase in complaints, there's a 0.75 increase in the variable rating. So as people increase on complaints, their predictive value for rating also increases. And on the right here, we see that there's 3 stars. So it is statistically significant. So somebody asked, can we set a 90% statistically significance level instead of a 95% and change the significant codes? The answer is I'm sure that you can. R is extremely flexible, but I want to point something out to you really quick. You see right here, or does everybody see right here this little period, and if there's a 0.1? So remember that the value here is what proportion of error you're allowing the model to have. So a 90% statistical significance allows 10% of error, and 10% of error is 0.1 as a proportion. So if something is significant at the 0.1 level or 90% statistically significant, it will have a period next to it instead of a star. So what you would just want to do is look at the output, and anywhere that there's a period, you'll know that that is statistically significant for you since you're using the 90% cutoff. This 90% cutoff is really common in exploratory research. It's also really common in disciplines that have really small sample sizes. So if you're doing some sort of a trial that only has 30 people in it, you may be using a p-value of 0.1 versus 0.05. And I know that earlier somebody mentioned that they're in public health. A lot of times public health and demographers use a statistical significance of 0.001. So they're allowing 0.1% of error or 99.9% statistically significant level for their analysis. So just adjust based on what you do yourself and interpret accordingly. That's a really good question. Great. I'm glad that it was helpful. Below that, you'll see that we have our residual standard error. It reports the degrees of freedom for the standard error. Remember that your degrees of freedom for your error and your model will be the same. So if you are in a discipline that really cares about residual, there's that value for you. Most of us definitely spend time on this next line. This is our R² value. So you want to use the adjusted R². The adjusted R² accounts for the number of independent variables in the model and make sure that you don't overestimate. So currently our adjusted R² is 0.66. That's pretty high. That means that 66% of the variation in rating is accounted for by the variable complaints. So this is a very good R-squared. This is pretty uncommon in sociology. In sociology, we usually have a smaller R-squared. So in my home discipline, we would consider this good, but in other disciplines, you may have a higher threshold that's acceptable. And then following that, this is the model fit statistics. So let me say that again. This is your model fit statistics. You need to make sure that you report this, especially if you write an American Psychological Association. This is your F statistic, right after where it says F statistic. And then you have on 1 and 28 degrees of freedom. So you would report a 28 F. And then this is your overall model fit. So our p-value is really small, which means that the model is statistically significant. So I want to quickly walk through this again and hit the high notes so that you kind of know what we have here. So we're saying, show me, the top section is the residuals, so that's the errors. The next section is the coefficients. Anything that has a star is statistically significant, or if you're using the cutoff of 90%, anything with a period or a star is statistically significant. The far left is the estimate, and that tells you what the value is. If the value beyond the intercept, so here, if it is positive, that means there's a positive relationship. If it's negative, that means there's a negative relationship. Our significant codes are following right after. This is not specific to the model. Everything else on this page is specific to the model. This is a default on all models. Then we see our standard error information. If you're in a discipline that reports that, our 2 R-squareds. Most of us use this adjusted R-squared. So 66% of the variation in the dependent variable is accounted for in the model. And then lastly, this last very important line, please don't ignore it, and it's your overall model fit. So we see here the F statistic, so that's your F score, your degrees of freedom, and followed by your p-value. So this tells us that we have a really strong model fit as well. So the next thing I want to show y'all is how to produce the ANOVA table for the model. Now, I fully recognize that most, I would say the statistical majority of us use this summary table only, but I know that there's at least a couple of you, because I've worked with you or I know your home disciplines, that you'll also need the ANOVA table. So the ANOVA table for the model is really simple. It's just simply ANOVA and reg model. Remember that ANOVAs and logistic regression both fall into the home discipline or larger category of general linear models. So we would run an ANOVA as well. When that's produced, it generates this little baby bit of output. So the first is your degrees of freedom. And that's for attitude complaints when predicting rating. So attitude complaints when predicting rating, PDF of 1. The next is your sum of squares, then your mean square, and then your F value, and is it statistically significant? Now you'll notice that there's 2 rows here. The first one is on complaints. This is your independent variable. So if you group by your independent variable, is it statistically significant? And then the second line is the residuals. Remember from earlier, I mentioned that the residuals is the error. So it's the summation of the error. It's the difference between the actual value and the predicted value. So if I predicted you would have a score of 25 and you actually have a score of 20, that means that the error is 5. And then if I add up everybody's error, that gives me my residual. So the first line is how well does the independent variable predict the dependent variable? And then the second line is how much error is there? So a good kind of marker is looking at the sum of squares and the mean squares. These are the values that I look at the most. If your sum of squares and mean squares is notably bigger than the residuals, that means you have a really good model fit. But if the residuals are off the chart huge, it usually means that you don't have as good of model fit. Do not think because you have residuals, you have a bad model. Almost have residual. Especially those of us who study humans, we cannot predict humans accurately all the time. There's going to be a human factor. There's going to be a component that varies for each of them. So after the ANOVA, we have confidence intervals for the model. So if you want to look at the confidence intervals, the code is confident and then the name of the model. So you'll notice that there's a consistency in looking at the results for each of these. Summary is the general results, ANOVA is the ANOVA results, and confident is the confidence intervals. So I'm going to highlight this, hold up. And it gives us just a little baby bit of values here. We have the 2.5 and 97.5. So why do you think that R gives you 2.5 and 97.5? 2.5 and 97.5. Stephen, I'll get to your question in just a second. What? Yeah, because if you take 5 and divide it by 2, that's 2.5. So why would we take 5 and divide it by 2? Because it's 95% common. What does it mean if you split the error at the upper end and lower end? So why are we splitting the error both upper and lower? Why do we do that for confidence intervals? We're splitting the error. Why aren't we putting the error on one side? Why are we splitting the error upper and lower? Somebody said so it doesn't skew left to right. That's a really good guess. That's not quite it. Somebody else said one tail. So the reason that we're splitting it is because we're testing a null hypothesis. Remember that a null hypothesis says that they're different. Or, null hypothesis says they're not different. So if we reject the null hypothesis, we're saying that they're different from each other. So if you have a one-tailed test, you're putting all the error in one side. So that's saying, I think that X will be higher than Y. But what we're testing is there a relationship between X and Y? So it's a two-tail. We split it on both ends. This is something that is nuanced, but it's important to note if you're going to talk about the confidence intervals, you take the error and you split it on both sides. Because as a general rule in statistics, we allow 5% error. If you take 5, divide it by 2, so you can split upper and lower, that's 2.5% and 97.5%, because 100 minus 97.5, or 100 minus 2.5 is 97.5. So this allows us to cut off kind of the tail ends of our regression model to help it fit a bit better. So if you're in a discipline that uses these confidence intervals for the model, this is largely going to be, I know APA style reports this. This is the way that you would get that. So the reason I wanted to show you all, I don't know if you noticed, but I didn't ask it. Does anybody have any questions? Because I wanted you to look at all of these results before we talked about any of them specifically, because a lot of times the questions are rooted in another section. So if you have questions, I'm going to kind of pull this up so you can see more of the output. If you have questions, type them in the chat, and I'm going to address the question that was from earlier. So it's saying, would we choose the predicted values, or would it be something standard in our data? When you say predicted the values, what do you mean by that? So the question is, would we choose the predicted values, or would it be something standard to our data? Can you explain what you mean by that, please? And then if anybody else has any questions, if you could post them in the chat, please. Oh, for the residuals. Usually we use 95% confidence, but if you're, somebody asked earlier, can we set it at 90%? You choose based on what is standard in your discipline for the residuals. So in a lot of the work that I do, I use a 0.05, but there's sometimes that I only use 0.1 because I'm doing exploratory research, but that needs to be defined intentionally. The other way to really know how to define it is based on the journal that you want to publish in or the conference that you want to present at. Kind of look at what the standard is there. If you look at how to format the tables in a journal, it'll tell you what to report as the statistical significance or the residual points, but almost everybody uses 95%. Is there any other questions about regressions? Jeremy, can you address the question about how to export the output? I always just save it. I don't actually know the code to export all the output. So Jeremy or George, if you know, can you put that in the chat? Okay, so while, sorry, I just don't know the answer to that. while people are, Jeremy and George are working on that, I'm going to put up these overall practice questions. There's only 5 of them, so we're going to do it just like we did the code before, but we're going to cut it off in 5 minutes. So I just want to see how far we can get. So Jeremy said, I don't know off the top of my head. I suspect there's a package for exporting regression model outputs in standard formats. Is your question about how to export everything in the output or specifically regression models? Everybody else, if you want to start practicing on these practice questions, he wants to export everything, Jeremy. You know how to do that? If anybody wants to start practice doing the practice questions, as soon as they're right, I'll put them in. So, just for the recording purposes, the answer is basically highlight the output and paste it somewhere, is what George suggested. And then there's an option to do it otherwise. So calculate the mean, median, and standard deviation of rating from the database app. So the first way to do it, somebody put the mean. We're going to say mean attitude rating. I don't see one for the median. Oh, there's median. Attitude rating. Does anybody have the standard deviation? How do I run the standard deviation of this variable? Great, so we have, so SD is standard deviation. We have SD attitude rating. Great, so we have this one done. So the next one is generate a variable STD rating, that is rating minus the mean of rating divided by the standard deviation of rating. I'm going to run these so that they're below. So we want, these are down here if you want them. So we're going to generate a variable that is rating, STD rating, that is rating minus the mean of rating divided by the standard deviation of rating. What do we think? So making SD rating, that is rating minus the mean of rating divided by the standard deviation of rating. This is called standardizing a variable. So if you've heard standardization or standardized variable, that's what this is. Anybody have this? I'm going to start typing it in slowly, and hopefully one of you will. No? I'm going to act like I got a hand cramp to give you a second to type it in. Oh, cool. So somebody typed it in using the functions. Great, 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 great. So then there's another way that you could do this. Does anybody do it another way? that was right. Did anybody actually put the values in? Because you can also do that. Yeah, for sure. I usually find that people type in the values. So I'm going to do that right here. I'm going to copy. No, it's more than fine. Don't apologize. This is a learning opportunity. Also, I'm low key. Not that I don't care, but like passive person when it comes to learning. Like screw it up. Do it somewhere else. Everything's fine. You know, the purpose is to learn. So you could also do this as 6. This isn't as robust of code, but you could absolutely do it like this as well. Okay, so does anybody have this? It's fine if not. If not, I'm going to go ahead and go to the check-in because I want to make sure that I respect y'all's time and make sure we get out of here at 9 o'clock. Does anybody have this code? I'm just going to paste it in here. I'm going to call it Reg Model 1 just because we already have another one. And then how I would show the results for the table is I would say summary, Reg Model 1, and how I would show the confidence intervals is right here, confident Reg Model 1. So the reason I'm putting these in here is I want to make sure they're on the recording. So later when you go to check your own work. So when you go back to this, please, please, please run this for yourself. Yeah, and it's pretty common to get unexpected bracket or something like that. So if there's an unexpected bracket, just check to see where things don't match. And you can go from there. You could also, in this one, remove the bracket because you actually don't need it. Because you're taking that value, subtracting that one, and it's already in parentheses. Okay. So I want to make sure, I think it's really important that we respect your time. So what I'm going to do is I'm going to put up the check-in slide. If one of my really great colleagues could put the link in the chat, phenomenal. Thank you so much. My email address, there's the code to the workshop information, check-in, general information about GSU, GRIP, and where we're going to upload it. Last time it took me about 48 hours to get it uploaded because I had some technical issues. I'm hoping it won't take that long this time. But I'm going to stick around, answer any questions that you have that were yearning, burning, and still going on. And then feel free to email me. Let me know if you have any questions. You can also email George, and you can email Jeremy as well with questions. So I'll stick around until there's not any more questions, and then I'll head out. But I'm going to stop the recording right now.